everybody. Welcome to the DePINed podcast. I'm Tom Trowbridge, co-founder of Fluence and host of the DePINed podcast. Thrilled to have today Greg Osuri, founder of Akash Network, one of the earliest DePIN projects, if not the first. So thrilled to have Greg here to talk about Akash and the DePIN ecosystem. I don't think anyone has a better kind of handle on it and more experience in it than Greg. So with that, I want to quickly turn over to Greg. And Greg, first question I ask somebody, especially who's been in it as long as you, is, you were in it before DePIN existed as a term. And so given that, how do you define DePIN and what do you think about this term and how do you think about us, kind of the characterization of the whole space?
Yeah, so the way I think about DePIN is really a mechanism to use decentralization to improve resource allocation at a fundamental sense, right? The easiest resources we can think of, on top of mind that we use every day is computational resources, right? Which is connected to a physical device somewhere in the world. And that distribution is very inefficient because of gatekeepers, because of the structure that we have today. DePIN networks tend to improve the efficiency, right? So in compute, cloud compute, as you know, 90% or 95% north of capacity is underutilized, right? So Akash and Fluence and a bunch of us are trying to improve that. Same thing with storage. Most storage out there is underutilized, Filecoin, right? So, and then we see wireless networks. Most bandwidth is underutilized. You have heliums of the world. So DePIN is a movement to improve efficiency of what otherwise were not very efficient way of distributing resources.
Fair enough. It's a way to effectively maximize resource utilization. That makes complete sense. It's a very, high level philosophical approach, which I like. The one I've been using, and curious what you think about this, is crowdsourced physical, it's slightly more specific, but crowdsourced physical infrastructure bound together by a common software layer, secured and incented by crypto economics.
Yes, one way to put it.
It's another. You sort of philosophically approached like what it does and why it's beneficial, which is like kind of the purpose of it all, which I think, and why it makes sense, which is terrific. My definition is a little more mundane, I suppose, but that's terrific. Well, tell us. I imagine everyone listening knows Akash, but let's hear what Akash is in your words.
So Akash is what we like to call a supercloud. It's the world's first supercloud. The idea of a supercloud was kind of a amalgamation of industry as well as academic efforts dating back to 2013, 2012 timeframe, where when cloud was increasingly becoming one of the most important layers of humanity that holds our modern society together. We noticed that this layer of cloud was also increasingly getting very powerful, right? So that leads to heavy centralization, which in turn leads to inefficient way of distributing resources and pricing and whatnot. So if we can, on one hand, you have this like very inefficient distribution plane. On the other hand, you have lots of underutilized resources, right? Be it in data centers to home computers and whatnot. So what Akash does is it decouples. What a supercloud does is effectively decouples the resource plane from the control plane. That way, any cloud-capable compute can become a resource on the supercloud, right? Regardless of where it resides, as long as it's capable of hosting a cloud workload. And Akash is the first decentralized supercloud. So in a way, the user experience from a tenant standpoint is very familiar to how you would use something like a Docker Compose, which is a popular developer tool. Whereas on the resources, anyone with a computer, essentially a cloud-capable computer, can contribute to the resource, right? So this removes locking into a single provider or removes, a control plane that is heavily gated or centralized, which leads to other inefficiencies when it comes to stability and risk and whatnot, right? So it removes all those aspects. Now, if you've done any decent amount of scale in terms of deployments or deployments over server architectures, at certain scale things break, right? So for us, before we began Akash, I was working in Silicon Valley, hyperscale companies, companies like Demandbase and whatnot, where we were doing about 1 billion transactions a day. At that scale, you break, right? Something breaks all the time. And a lot of times, the control plane that controls all the other distributed systems is usually the biggest sort of like risk aspect, right? So by removing the control plane, remove the centralization of the control plane, and decentralizing means we add stability to the infrastructure network. So that's how Akash came into play. That hey, we figured out that centralized control planes are susceptible to faults, and if we can decentralize it, we can build a much better fault tolerant system.
And a lot to unpack in that, but one point you mentioned was any cloud capable computing. Does that imply it's not any computing? So does that you didn't say that? So does that imply that this is more data center oriented versus retail machines, or can retail machines be cloud capable as well if they're of a certain standard with a certain bandwidth access?
Yeah, that's why I'm very careful on using the words like cloud capable in the sense if it can join a cloud network and server workload. So in case you want a home computer, there are certain trade-offs of a home computer which tend to be around bandwidth, right? So computers are powerful, but bandwidth may not be reliable in a home. So it's definitely cloud capable, but in order to serve meaningful, make meaningful impact in a cloud scenario, this has to be an asynchronous style invocation for a job, right? So if your desktop computer or a home computer, a home network computer can connect to a cloud in an asynchronous manner, it'll be cloud capable, right? So Akash doesn't mandate any minimum requirements in terms of bandwidth and whatnot. It is a free and open market. So as long as your computer that's part of the network is capable of serving a workload and satisfactory to the tenant, your workload, your node can be part of the part of the workload, right? So
it's permissionless, and if a customer finds a provider that they're comfortable with, it could be an async type of relationship. It could be one that has a low bandwidth requirement, whatever. If the pricing is right, they're free to transact and to work.
Correct. So versus using it synchronously to host a API or a real-time service, which may not be ideal for a home computer, right? It can do a background job, but may not do a latency sensitive job.
And just philosophically, and I want to go somewhere else, but I have to go. If you think about this, because we think about this in Fluence a lot, if you think about the progression of hardware deployment in DePIN overall, not DePIN, in blockchain, you start off with retail, and effectively, and it moves pretty quickly, faster and faster to institutionalized providers. You've seen with Bitcoin, you've seen with Filecoin, right? Even Helium, you have companies buying up and deploying large numbers of hotspots. So I'm kind of curious, even though that's possible, how do you see the future of this going on? Do you see a run out of data centers, or do you see there will still be a role for this asynchronous or non kind of institutional level of participation?
Yeah, so it's interesting, right? So when you have institutional level participation, the participants optimize for efficiency. So packaging resources in the most efficient manner. And whereas, so that means you're going to have minimal underutilization, at least in theory, right? Because for profit, you're looking for maximizing, your yields, right? Whereas in a home computer, you're optimizing for different things. You're optimizing for usage, which is usually different from serving a decentralized network, right? So I don't think we're going to be either or. I mean, considering the amount of compute needed for, say, AI, is exponentially growing. And so we're going to see a surge in data centers, especially in places where it's, cost optimized for acquiring power, right? So places like Texas, and I think we're going to see quite a lot of, uh, you know, uh, areas where the government is pro cheap power, nuclear power or renewable power, right? While home computers or home power is actually very, very expensive, right? If you do it at scale, right? If you have anything beyond, let's say, a, a 4 GPU network, is you start paying a lot of electricity costs, right? So, um, in order for a home computer based network to be optimal, so it really depends on the job, but at a high level, you can say comes down to bandwidth, interconnectivity between different nodes, right? So especially in a neural network training scenario, right? Because the interconnectivity is a huge contributor to the training times, right? So, and there is quite a lot of innovation these days where they're optimizing on batch sizes and the gradient sizes and whatnot to do federated learning, but we're not there yet. So ideally, in a scenario, ideal scenario for Akash or Fluence or any decentralized network, I would say is hyper distribution, because that's less risky in terms of faults, right? But the trade-offs is you're going to deal with interconnectivity, and that if that contributes to your workloads, it's going to be difficult for heavily distributed systems. So I wouldn't say one or the other. I think it's going to be a good, healthy balance. But if you had a point where maximum availability exists today in terms of resources, it is really in the home computers. Like, I have a PlayStation at home that I use once a year, every year for Christmas. I mean, that really don't play that game much, right? So I have 2 consoles that I just sit idle, 360 days of the year, and that could be part of a computation network. And I have a desktop computer that I use maybe 50% of the time, right?
Right.
Or less, in fact, right? So I use my laptop more than my desktop.
And you may not even, in that home computer concept, the interesting thing is you may not even be aware of what your power costs are. And so any revenue coming in may be positive. So you may actually, despite the efficiency of cloud providers, you may be undercutting cloud providers because you're happy to take any revenue in, because it's effectively a sunk cost. So you could have areas where retail is actually effectively mispricing their assets because they're not thinking about return on invested capital. They're not even fully aware of the power costs, or maybe the power cost is subsidized. And so you could end up with even cheaper. You just don't have the scale. And so I'm kind of curious,
Right.
even on what you see being used on Akash now, is it data centers on Akash? Is it retail? Do you know, are you able to tell any of that?
Yeah, we can tell by the type of resources. Like, we can't tell exactly who's using, but by the type of resources, we get an idea if it's retail or data center. But I would say like 99% is data center grade compute on Akash. It's just we're not there yet with retail or home computer type scenario to be effective. Even with training jobs, right? I mean, think about it. If you have 4090s, it costs what, 450 watts for 4090 per chip, right? 4 of them is close to 2,000 watts, right? So there's 2 kilowatts. That's quite a lot for a home. So
for a house, yeah.
So any meaningful AI, and well, you can say M4 or M3 chips, which are powerful, but the software suite is not there yet, right? So you can't really meaningfully use any of the home computers for training, right? Because training is heavily towards like the latest and the greatest chips, whereas inference is optimized for older chips, but inference needs latency capabilities, right? And that could be a challenge. So, we're there, we're getting there, but we're not there yet.
Well, listen, you just dove into AI, and you went in pretty specific into inference versus training. So can you take a step back, and first let's draw the distinctions, because Akash does both, but CPUs and GPUs, and then you can further parse down the GPUs. And I'd love to hear about kind of how you think about those two markets. That's a whole podcast on itself, I suppose. But at least break out the two different types of hardware on Akash, and then within those, kind of where you see opportunity, where you see where you're seeing traction.
Yeah, I think instead of CPU and GPUs, I think broadly you can say that two. I guess you can put in two axes, but broadly you can say there's latency sensitive and there's batch optimized workloads, right? So latency sensitive workloads would be something like a website or an API, something that has to respond to user request in a synchronous manner in a in least amount of time, right? So for heuristics, you can say I think for the cognitive continuous time for every interaction to feel cognitively continuous, the interaction has to respond within 100 milliseconds. Right? So if a click or a touch on a computer, for example, or a device, if it comes back within 100 milliseconds, you feel the user experience is continuous. Anything beyond 100 milliseconds adds lag, right? So that translates directly to whatever metric you're measuring, usually in conversion rates, right? So we did this quite a lot of, I think Amazon did a study. It talked about how each 10 milliseconds in latency reduces your conversion rate significantly. So, and depending on what you're selling, if you're doing ads, it's even worse, right? So, and internet runs on ads. Sadly, that's the truth. So, latency sensitivity is, if that is a major requirement for your application, you're more likely to benefit from a data center grade system where you want to know what kind of bandwidth capabilities exist. Also, you want to know how close in terms of network proximity does that data center live to where your users are, right? So if you think about it, right? So if you, let's say, east to west coast United States, the latency is about 300 milliseconds, right? That's quite, I mean, in a regular average line, not talking about a direct line, but average interconnect, hop through two different, if the user is in West Coast and the server is in East Coast, it takes about 300 milliseconds. It's quite a lot. So when you have your users in West Coast, you want to have a data center in West Coast, right? LA to San Francisco, for example, has about 30 milliseconds, which is very good, right? So you can serve your users in California. So if you're, say, having 30 milliseconds for your West Coast users, then you have 70 milliseconds to work with from your application standpoint if you want, good performance, right? So that's very small window. So in that 70 milliseconds, we're talking about all the things your application need to do, all the way to from understand the request to calling your database or doing what it needs to do and come back within 70 millisecond tail latency, which is very hard. So that for those kind of scenarios, you have Akash gives you this granularity in terms of like selecting a node in California or and making sure it has certain tiers when it comes to data center grading, making sure it has a phenomenal bandwidth. All that Akash will give you an ability to select, right? Whereas you have something like a batch workload where, say you're training, right? So you're training, or you're doing something like forget training, but you're doing a big data job, right? So you have millions of records you want to, clean up and store in a database, right? That expectation for 1 million records to complete within a period of time is lower, right? So because you're going to take the upload from your website and you're going to be like, look, I'm going to process these in a batch. In a scenario like that, it really doesn't matter where how fast the latency, as long as the price performance is within your budget, within your range, right? So it comes down to like how much dollars I'm paying to process, let's say, 100 jobs. It becomes your unit of success, right? So if a home computer is offering for you significantly lower cost and their bandwidth is shared anyway, you can make an argument saying that, hey, I could use a home computer, right? Which is going to be beneficial in terms of price performance for me. So that's where we see the batch optimized, right? CPUs, and usually batch optimized have GPUs involved, right? So most of the inference calls take longer than 10 seconds. I mean, longer than a second. I mean, to respond. So I would consider inference calls to be kind of like a batch workloads, because you can do an asynchronous call, because the latency is significantly lower for the most part than than the actual inference call it takes to respond. So yeah, so broadly speaking, latency sensitive and batch sensitive is how we look at it. And then you have these GPUs and CPUs, right? So GPUs are accelerated compute and CPUs are regular compute, right? Accelerated compute is a must for certain workloads like AI, whereas some AI can run on CPUs as well, but most modern AI needs a inference capable, accelerated compute, be it 4090s or be it A100s. Whereas if you're training, which is a significantly computational intensive task, requires more advanced chips, be it H100s, B100s, and others, right? So Akash offers both.
And so you offers both, and help everyone understand the distinction. And the CPU market is vast, but the GPU market is growing, as you said earlier, exponentially. So when you think about those two markets, is it easier to get a share of the market that's growing versus the existing market that's much bigger? Is that one? How do you sort of think about addressing each of those two markets with very different characteristics?
Yeah, I mean, there's no right answer. I mean, they go along with both, right? So it really depends on what your product is offering and what trade-offs that we look at from your offering, right? So, the argument of like, do you take a big market and offer something compelling in a big market, and approach your go-to-market that way, or do you identify a niche market, offer something valuable in that niche market, and go for market share, right? So there's no right answer, but the approach we've taken is effectively really looking at what Akash offers to a traditional Amazon user, right? So, or traditional Web2 user. From a CPU standpoint, Akash, yes, taps into underutilized resources, the pricing is lower and all that good stuff, but who's it appealing to, right? If you go to an Amazon user, Amazon's users appeal is not necessarily cost all the time, right? It's 10 times cheaper, right? Cost maybe at scale, sure, but Akash is nowhere, at scale as Amazon, right? We're talking about like spending hundreds of thousands of dollars per month, right? If you're saving, let's say 10% or 20% or 30%, when you're spending $100,000, is meaningful. But if you're spending $100 and saving 30% may not be meaningful for most people. So Akash doesn't offer that level of scale and savings at that level of scale for computational resources, compute, right? But if you're doing something like mining, where you are, when you're just like really optimizing for price, and then you really want to get something super cheap, regardless of where it is, Akash is great, right? So there's certain type of workloads Akash is great for when it comes to cost savings, but generally speaking, unless we hit the scale of Amazon, and which we will, but not the state at which currently Akash is not like compelling from a CPU standpoint when it comes to cost savings. Well, so you take the other aspect, productivity, right? Akash, from a toolchain standpoint, is it better than Amazon or worse than Amazon, right? So that really depends on who you're asking, what type of user you're asking, right? So if you are crypto native, in the sense you are in crypto, the user experience is phenomenal, right? I mean, there's no email addresses, there's no credit cards, it's non-custodial, it's beautiful, it's you can do lots of things that took you forever on Amazon in a few minutes on Akash, right? So it's really container optimized. So if you are, again, there's another challenge, right? So if you like containers, if you work with containers, if you understand what they are, Akash is phenomenal. Now, if you're not a container person, if you are a VM person, Akash may not be great, because your behavior change that you need to use containers is significant, right? The expectation that you would come to a website and click, upload your SSH key and get an SSH access is not the type of experience you gain. But if you want to come and deploy like 100 containers in 10 different regions in a single click, yes, that's something you get out of Akash, right? So it's like taking a Ferrari to buy groceries. Sure, you can do it, but it's the worst thing to do, right? Like, so that's the sort of analogy. What we need to do is build a Ferrari that you can take to groceries, which is a different design problem in itself, right? So that's why CPU networks are not that compelling for Akash users, because the value it provides is not that great in terms of in the current situation as it is. It's great when it grows, right? So GPUs, on the other hand, is something Akash offers that no one else offers. Centralized cloud cannot, right? Like if you go to Amazon, for example, today, get an A100 and H100 on demand. If you're lucky, you may get if you're lucky, that is, you may get on demand, but you'll end up paying for H100 about $12 an hour, whereas compared to Akash, which is about $1.59 or under $2, right? Which is amazing. So, and its pricing is out of reach for most people that are doing machine learning at scale. Not even at scale, just basic research, like university students to startup companies that want to get a set of 8 chips on Amazon. Is impossible, right? If you go to the Lambda and the other guys, the tier 2 ones, you're required to get into a longer contract even to get the chips. So on-demand access is on-demand for general purpose compute. I mean, there's other on-demand,
like a serverless concept, right?
General purpose. So Akash is not serverless, right? So again, serverless is broad, sort of like area not to get into. But what is serverless? What's not serverless? That's a whole
fine.
Subjective, right? So for me, a serverless is something where you don't have to touch bash or shell, right?
Okay.
Serverless, I think for me, is something that you're natively writing in a language, be it JavaScript, be it Python, and you just stick with that native language to deploy, right? So the moment you start breaking down into like system level stuff, I think you break the serverless paradigm. Now people say, okay, serverless is something that you may not is container based. People consider it to be serverless. I have this blog post from 2016 or 2015. I made a case saying that serverless includes containers. So I'm in that camp. I'm not in the functional as a service camp.
I have a far simpler definition. I would think it's just something that is contractless or is machine specific with duration, if that makes sense. It's sort of it's more call based versus duration based. Is that too simple?
So the pricing is per invocation versus duration. Okay, that could be. Yes, I mean that's a key property for serverless, right? I mean you pay per call, effectively. But also I think the value I find in serverless is quick to market, deploy. Right? So right, so I have a function and
boom, it's available.
And I deploy available. I don't have to go set up the container. I don't have to set up dependencies. I don't have to set up all the stuff. And the trade-offs is like, you pay per call, which is great if you're getting to market quickly. But then when you start scaling, it becomes challenging, the overhead and all that stuff, right? So again, it's a different sort of like different trade-offs, right? That you incur. Like as a busy executive, I prefer serverless. But if I'm like looking at performance tuning, I probably will go monolithic, right? So, So Akash is like, it's hard for easy use cases, easy for hard use cases, and that's a challenge. With GPUs, we have something that no one else has. So that value prop is clear and easier for folks to understand, especially folks that are skeptical about crypto or crypto-based networks or decentralized networks in general. The activation time for people to use Akash for non-crypto user is very, very high, because the value for GPUs is significantly higher than cognitive load someone has to incur to use Akash. We have product market fit.
And so, I guess earlier on, you mentioned that the value proposition on the GPU side is A, more availability, and B, far cheaper pricing. It's kind of hard to see how you lose with that combination, right? You can't get it somewhere else. If you can get it, it's way more expensive. That is a very compelling value prop. And there's also, besides that, there's the whole benefit of providing that to, on a shorter term contract basis to people, a much wider variety of people, to sort of democratize the access to it, which I think is a huge benefit to what you're doing as well. But I am surprised that there isn't the same cost benefit on the CPU side. Availability, I believe, there's probably availability on CPU, so you couldn't get there. But I would be surprised there aren't sunk or underutilized CPUs that could be on the network far cheaper as well. Is there a reason why you don't think that's the case?
We do have significantly cheaper CPUs on network. The problem with CPUs is, well, there are two problems, right? So the first problem is we only get underutilized CPUs, not the ones that have high demand. So we end up getting, the CPUs that are less attractive in terms of, power. How old they are, they're slower, and they're usually not used, right? So your application has to understand that profile. So folks that are deploying on Akash are expecting Amazon level, performance, and then you come and you get, wide variety of options. Usually the ones that are high quality are not cheap because people want them, right? That are low quality are cheaper if your application can leverage those. And second is we have reclamation pretty heavily, in the sense people reclaim resources quite a lot in CPUs more than GPUs, we noticed. And cloud in particular, because of granularity Akash offers, is impossible to commoditize, right? Because there is it crazy. I don't know how you guys do it in Fluence. I'd be curious to hear your thoughts as well. There are too many dimensions to price CPU-based cloud for it to be an effective commodity, right? So that makes an order book challenging, very challenging in terms of pricing, right? So that's why Akash doesn't do pricing as a protocol level. It differs the pricing to the provider and the tenant. So that makes it very variable. That makes it non-consistent. That makes it so you may get 10x cheap price today, but tomorrow you come, the same resource would cost you sometimes even expensive than Amazon, right?
So fair enough. I think that's how we're behind. We're sort of not as advanced as you are in our deployment, but to your point, first the hosts are going to set the pricing, and the pricing is going to differ based on what service is offered, to your point. So it's not as much of the commoditization of a CPU. It's what service is being offered, and that leads to a wide variety of pricing. And then frankly, you start to get into all kinds of service complexity when that goes on. So I definitely agree with you there.
So I think you guys take a level abstraction, right? About just raw resources. That's why going serverless, when you're pricing per call, is very different than you have similar heuristics as Amazon Lambda, right? Which is easier. I think they charge by memory as a resource, and memory consumed by time, right? So per call, I assume. You always have to go higher in order to get any degree of commoditization when it comes to general purpose compute, right? So we're working with a bunch of folks to get true pricing as well, and a very active area of research. There are experts, sadly, on Wall Street that figured out how to commoditize high dimensional assets. We figured out how to commoditize diamonds for a little bit, I think, to a degree. Gold is easy because there are a few dimensions, but diamonds have a lot more dimensions, right? So GPUs are easier to commoditize, significantly easier because there's less dimensions.
And on that point, and then, by the way, we're still on my first question, by the way, but on that point, do you see this GPU advantage you have persisting, where or the cloud provider is going to, in the next, pick your time frame, 3 years, 5 years, be able to order enough that they actually will have it to give? Or is the supply growing, the demand growing so much that they're going to get it and they're going to quadruple their supply, but it's going to go to their big customers? So Akash is still right in the sweet spot of being able to offer this available versus unavailable at a cheaper price. How do you see that market over the next couple of years?
Right. So Nvidia is going to be the most valuable company in the world, right? So what that means is there's clear demand for AI. There's clear demand for chips, and demand is actually gaining, right? I think Gartner predicted, for, for what's worth, that 5% of global GDP will be spent on compute for AI. So demand is clearly going. I mean, that by 2030, that's pretty aggressive, right? So demand is definitely, growing. Supply chains are catching up. But interestingly, what they're doing is the models are evolving at such a rate. I'm talking about GPU models, right? It was H100, then this B100, now it's R100. There are new chips coming out every 18 months. Moore's law is broken when it comes to GPUs. Nvidia, without any real competition, is innovating at such a speed that the fabs are not catching up, right? So, Nvidia relies on this company called TSMC for fabrication, and TSMC needs 18 months to retool for every new model, and has a 2-year, reservation requirements for each fab. So it's like, what we're noticing is the supply chain is actually getting better over time compared to this month, to last year, right? So we have seen significant improvement. So if you how to put a prediction, I think supply chain will ease out in the next 3 to 5 years, right? I don't think it's going to be forever. Compute, shortage. On the other hand, you also have an enormous infrastructure of data centers that are being built for AI. We're talking about, there was a disturbing trend where hyperscalers were taking over in terms of data center count. There was like 8.2 million data centers 10 years ago, which reduced to 7.5 million data centers now. And increasingly concentration happening over for hyperscalers, but that's reversing. We're seeing smaller data centers now that are popping up everywhere with GPUs on them, right? So I don't think hyperscalers are going to be the winner take all in this market. Fortunately, I think it really comes down to Nvidia, how they want to distribute the chips, and they have complete control on how they do it. And so far, they've been optimizing for more distribution and less concentration, because that's in their best interest, right? So concentration is purchasing power, negotiation power, and they don't want Amazons and Googles of the world, which traditionally have been very hostile to Nvidia. So fortunately, I think the resource is controlled by a different company that's not distributing the resource. So distributors and the resource are different, right? So that gives me like hope that you're going to have more distribution, more than concentration of resources. But then again, you're going to have competition that's popping up to Nvidia, right? So you're having, there are ASICs now that are, for context, Nvidia has a big leg up when it comes to GPUs, not because they make the best hardware, because they make the best software. CUDA. CUDA undoubtedly works. For anything big data, CUDA is the best toolkit and best vertically integrated software with hardware. I mean, AMD is so embarrassingly bad. I don't know how much you work with AMD, but the stability of the drivers is so poor. You can't do meaningful work on AMD even till date, and it's really sad. There's really no competition to CUDA. On top of just an amazing, stable driver set, CUDA also offers optimizations. Like, you can reduce training time by 30% using certain techniques. It offers all this incredible. It's a toolkit. It's SDK. It's just a driver, right? So, no one is close to getting there. Intel is trying a few things, but not even close. So there's no real challenge to the most valuable company in the world to be a valuable company in the world. So I don't know if there's going to be another contender that's going to immediately threaten Nvidia's position in the next 5 years, right? So considering that Nvidia is going to have monopoly, as sad as it looks, considering they're going to control the distribution to optimize for more distribution and less concentration, considering the demand for AI is just going to increase, that means Nvidia is going to just
keep
going. I don't see supply chains improving in the next 5 years at least. I mean, not improving significantly in the sense that it'll be marginal gains, but not step gains, right?
Well, and so I mean, a couple of key points to pull out of that, I think, is one, Nvidia's self-interest is in having a fragmented GPU market, which helps Akash and other independent providers, and that's their own self-interest. Great. To the extent there is additional competition, that should also lead to additional fragmentation, should not lead to one provider getting stronger, you would think, because everyone had the same interest, you would think. And then the other point you mentioned, sort of the growth, is that, and this is just a point you probably take for granted, but just so people recognize it, the reason why GPU demand grows so much is, I think, for every, pick your number, at first, 50% improvement required doubling the GPU power. And then, from that point on, 25% required doubling of GPU power. And then from that, 10% required. So basically, phrasing it the other way, the doubling of GPU resources results in an ever decreasing amount of improvement, which requires the growth of the GPU market to continue the LLM and other AI improvements. Is that a fair way to think about it? You know
Sure.
more about it than me.
Yeah, sure. And also another interesting fact is the models themselves are getting very advanced. The actual LLMs, right? So the more advanced models get, the more computational power they need, right? Like, you look at GPT 4o, which is significantly slower than GPT-4 or GPT 3.5, right? Because they are, trained to need much power, right? So if I have my phone here, if I want to invoke like the ChatGPT, so I click this here. It takes forever to just pop up. Like, that is, it takes, in one question, it takes forever to respond, right? So ideally, I want that to be much faster. Only way to get that faster is to get more chips, right? So we're not, from a product standpoint, AI is not even close to being embedded in our everyday products because it's not fast enough, because there's not enough chips, right? Imagine ChatGPT part of Siri, right? And that's happening right now. People have a tie-up. But imagine the amount of compute you need when you have to power Siri. They have billions of phones around the world and billions of devices, as a matter of fact, phones and computers and whatnot, right? And watch, your Vision Pro and all that stuff. So I don't see like the supply chain is getting any better. It's too sort of, in a way, it's too scary to even think about it, right? If you think about, there are only 3 companies in the world that run the AI, or that make AI possible, right? You have ASML. ASML is the company that makes machines for the fabs or the fabricators, which is based out of Netherlands. And then you have ASML, which makes the chips, the hardware, for 60% of the global semiconductors. Then you have Nvidia that makes the hardware and that designs the hardware and the software. So if anything were to happen to any of these companies, the entire globe will stop when it comes to AI. So it's kind of scary in a way. So I want to see more ASMLs and TSMCs and Nvidias. I think just from a stability of a global supply chain, and these takes billions, hundreds of billions of dollars to even get to diversification of this heavily fragile supply chain. So yeah, so to come back, the need is just going to go crazy, and because supply chains aren't optimized, and people are working on it. I mean, Elon Musk raised 10 billion. That's not
six billion.
6 billion. I think there's somewhere he's raising 10, but that's not close, right? To what you need to even build a fab, you need a lot more money than that. There's CHIPS Act, which granted $52 billion. Most of that went to Intel, that is busy buying executive jets more than innovating, right? So I don't see the investments going to the right places. And Nvidia, and this geopolitical scenario where TSMC is holding, I mean, even though they're supposed to bring TSMC facilities to Arizona with the CHIPS Act, they're only bringing 7 nanometer capability, or not. They're not bringing the 3 nanometer capability, which is needed for H100s. Forget the 1 nanometer; they're not even.
Yeah,
I mean, they're developing, but they're not bringing that to the United States because that's national security for Taiwan. So there's this geopolitical, tensions that's preventing supply chain. So looking at all these aspects, I don't see supply chain improving anytime soon. And China's aggression on Taiwan is for the chipsets, right? And there's a degree of protectionism happening with the global geopolitical landscape. Banning advanced semiconductor sales to China and whatnot. That's going to slow down global innovation, right? So I don't see how this protectionism, this geopolitical tensions, and this fragile supply chain improving anytime soon.
Let's shift gears for a second. Can you talk back up and talk a little bit about your background and what kind of brought you to Akash, and kind of what in your experience has made you kind of the effective kind of founder of Akash that you are?
So before Akash, I founded a company called Angel Hack. Angel Hack was responsible for making hackathons a mainstream concept. Before Angel Hack, hackathons were a very underground concept, and Angel Hack literally took that underground concept and created the modern day hackathon, the format, right? So we helped launch several companies at Angel Hack. The most popular one would be Firebase. It eventually got acquired by Google and became Google Firebase. It was launched at Angel Hack by Jim Stamplin. So we had several incredible Web2 companies launch at Angel Hack. There's even rumblings that Lambda Labs was incubated or thought about at Angel Hack, according to Steven. So there's a lot of really good things came from there. About 200,000 developers spread across 50 cities. That's where I really developed a passion towards developer tooling and making, a challenge was if you can take at a hackathon, you use Heroku to deploy your application, you get to the 0 to 0.1, 0.5, right? And then you go, in your endeavor to get to 0 to 1 to 1, essentially, you develop an app and you optimize for simpler deployments, right? The moment you want to scale, it becomes very, very challenging on Amazon. And if you do anything scale, like I was working in Demandbase ads company, and they were responsible for I think 60% of all account-based ads. I think it's a public company now or going public. Massive operation. They're doing a billion ads a day, in thousands of servers across the globe. A lot of Amazon and a lot of non-Amazon. What you learned is at scale. I mean, all these orchestrated using traditional VMs, right? This is 2013, right? And we found containers to be a lot more, at least promising when it comes to deployment at scale. Google famously made containers popular, and I fell in love with containers 2012 timeframe. And there's this package called Docker that was launched, made containers easy to use from libc, and and ran into a guy who was building this tool called Kubernetes in 2014 timeframe. I was working on a different. I was trying to make containers more fault tolerant. I was building on a paper called Omega that Google released as an optimistic scheduler because containers were great for packaging and deploying, but back then they didn't have fault tolerance or any scheduling capabilities. Right, you still had to manually schedule. So writing an automatic scheduler for containers, there was this whole effort by so many different people. Right, so Ali Ghoshi from Databricks, he built Mesos. So in Berkeley, right? So that was the main container orchestration like scheduler, which is pessimistic in nature, and I wanted to be an optimistic scheduler. So so that work led into me contributing to Kubernetes because Kubernetes had a monolithic scheduler based on something called Borg, built in Google. But importantly, it had an orchestrator, which containers didn't have back then. Orchestration scheduling is very, very important, but the difference between pessimistic scheduling and optimistic scheduling only makes sense at scale, but for general purpose, a monolithic scheduler Kubernetes offered was great. So I started working more on the orchestration side of things. I helped design the multi-cloud sort of like capability. There's this demo somewhere from 2015, me showing Kubernetes can scale out to multiple global clusters. This is before anyone heard of Kubernetes, right? So wrote a bunch of open source libraries that got adopted really, really well in Kubernetes community, Docker community. Nvidia, in fact, uses some of my libraries that for their Kubernetes drivers, right? So if you use Nvidia Kubernetes, you probably use my code. AWS CLI uses my code. HashiCorp, Nomad, Terraform. A lot of the early 2013 infrastructure, cloud native infrastructure, protocols or sort of products that are widely popular today ended up using my code. The libraries I wrote originally for Kubernetes and for Akash. So that led to really designing systems that work at scale and schedulers or the control planes when they are decentralized work significantly better than centralized control planes at scale. And that's how from Kubernetes multi-cloud to Kubernetes multi-cloud using control plane that's not centralized is what Akash is, right? So it's been a journey for 10 years and we're still here.
Super interesting. Super interesting. That's I didn't realize that. Can you dig into something I think people here care about? Talk a little bit about token economics and how does Akash think about token economics? Because that's a big, obviously, topic in the DePIN space.
So a token for Akash has not. It was almost an accident that we ended up with a token. We did not start with a token. In fact, when we started Akash, it was in 2015. At least the decentralized aspect of Akash was in 2016 timeframe on Ethereum Frontier, which is early smart contracts platform Ethereum. We actually used ETH as a currency for payment, right? We didn't need Akash AKT token at all, actually, because cloud computer just pay using your regular dollars, right? This is before stablecoins, before any of that stuff. The problem with ETH was, well, it was unstable, but also Ethereum at decent scale crashed at CryptoKitties launched, and we're like, not going to work out for us, right? And then we decided to do a layer one, but then the consensus scheme for layer one was proof of stake, proof of work. I think Vitalik wrote about proof of stake back then, 2017. But also another guy called Jaquan, he invented, actually Tezos invented delegated proof of stake, but Jaquan, I think, took that and came up with BFT consensus, right? So using delegated proof of stake called Tendermint. So we really like Tendermint, but in order to secure a Tendermint-based chain, you need a token in a proof of stake scheme. So the token came because we needed to secure the network, and then you have governance, right? So we started building upon each layer by layer. Well, governance, great. One token has one vote, so who makes changes to the network needs to go through governance, right? So token holders effectively become the participants. Now we have 230 proposals on chain. About 30 of them are funding proposals, and we have this whole ecosystem now, right? That's around AKT. And then we realized, like, look, a provider like coming from open source world, right? So Kubernetes obviously very successful. We studied Kubernetes community organization. We replicated that in Akash. We realized that Kubernetes has a contributor churn. So contributors don't stick around for Kubernetes. It's now become effectively a bunch of enterprise companies just that sell Kubernetes contribute back to Kubernetes, but real contributors don't contribute anymore. We could solve that through creating an ecosystem that is self-sustainable on using tokens, right? So tokens effectively began as a security mechanism, then became governance mechanism, then became an ecosystem mechanism. And of course, AKT is the primary way people pay using, on the cloud. But again, it's volatile. It's not great, right, in terms of value exchange. So we have support for stable currencies now with some degree of value capture going back to AKT tokens, right? So yeah, and then we realized when the whole incentives started kicking in, we're realizing that, hey, you can actually incentivize behavior. I wrote a paper in 2019 called bootstrapping a free market by borrowing from the future, effectively using token incentives to incentivize behavior. And that, I mean, we're talking about 2018, 2019, before tokens were not used for any incentive mechanisms, right? I mean, DeFi really showed me one way that, hey, you can actually gain liquidity by using tokens as incentives. So we applied that mechanism in Akash. We haven't implemented incentives because we want to get organic demand supply. So like AKT token is used for paying, providers, but providers only get paid if your node is used, right? Obviously, that has various degree of liquidity. Liquidity profile is so diverse, which is not good because you want high quality compute. So in order to attract high quality compute, you need to have some degree of incentives. That means prepaying users, providers. So now we are in a pilot for incentives. So we should with the pilot, we're able to track H100s and A100s. And hopefully this pilot will be complete by end of the year, and we can do on-chain incentives. And there are a lot of challenges with on-chain incentives for general purpose compute. So working through all the nuances and whatnot.
I mean,
so you're not rushing. Yeah.
No, fair enough. I mean, it sounds like you started so long ago. The market and the capabilities have evolved so much, as has the expectations of people who are market participants. So you're kind of building it. You're almost like building it as it's built. You're rebuilding pieces of it while it's all working. Most people start with the token bit and then figure out what else to do. You've got a working product, a working network, and you're now layering a token on top of it, more or less. It's already working already, but you're just adding other pieces to it.
Can Akash work without a token today? It can work without a token if there's a layer one that can support Akash. Unfortunately, there is no layer one that can support Akash. And we realized that after trying different layer ones, right? So the only model that worked for Akash, now this may not be the case 5 years from now, right? 10 years from now. Let's say, the layer ones have gotten really, really good that you can support the whole globe. And then Akash doesn't need a layer one. Now the question becomes governance. How do you do governance, right? How do you make changes to the protocol? And without governance, your protocol becomes stagnant. Can we use Bitcoin as a mechanism to do governance? Yeah, but then you're saturating your community and you're attracting everybody in the world that has Bitcoin to have a say.
Yeah, and so, they don't. Yeah, without expertise or passion or whatever.
So it's challenging to remove a token out of Akash now because we learned all these capabilities as we went about. We didn't start off with hey, token is going to do X, Y, Z, because we were not token people. We didn't really care about token. I mean, the whole reason why Akash exists is a decentralized control plane and better efficient use of resources, right? But we ended up creating something where the security reliability reliance on the token means the token has to be the value of the token has to be proportional to the economic activity of the chain, right? So if the value of the token is lower, then it becomes susceptible to attacks. So the value has to go up as economic activity goes up on Akash. So it's integral. So crypto cannot be decoupled from blockchain at this point, right? Especially in proof of stake network, it's so integral to Akash. In fact, we're actually exploring quite a lot on how to leverage. If you want to truly, I'm a firm belief that if you want to create a truly decentralized system that's extremely strong, can withstand state level attacks, you got to look at a network that is only is capable of withstanding state level threat actors, which is Bitcoin. So we're actually looking at bringing Bitcoin security Akash. So we're actively researching for other consensus mechanisms that could reduce the reliance on Akash token as much as possible, because I believe Bitcoin has to be the mother chain of the world. I mean, it is kind of the most secure chain in the world, right? So that's where we stand on tokens.
Well, I have a Bitcoin question, but I'm going to save it for a second. Before I get to that, help us understand. You talked about 5 years future. Help us understand scale. Where do you think Akash can be? What are scenarios you think about in terms of how big, your network, your marketplace, however you define it? How big do you think it can be, and whatever metrics you choose to articulate it?
Man, I don't see $1 million Bitcoin out of reality, right?
No, forget Bitcoin for a second. I agree with that. I 100%. But I'm just thinking about Akash. How do you think of Akash scale?
At scale, Akash, right? So there are 10 billion devices in the world. Akash can technically get to all 10 billion, technically, right? So there's no reason why a self-driving car just sitting idle and charging should not be part of a global computational network, right? And permissionless systems are amazing because you don't need anyone's permission to run the node or participate in the node. And the only requirement is, can the node run on your device or not, right? So Akash will continue innovating, on device support as much as possible. And right now, Akash can run on ARM devices, but I think it's getting better and better and better, right? So it still requires significant, capabilities in the computer for anything meaningful workload. But once we figure out incentives, once we figure out all these aspects, I think it's just going to go, easier for providers to deploy in their networks now.
So it's a huge amount of scale potential, is what you're saying. I mean, that is effectively limitless scale. I mean, effectively what you're saying.
And what I want to do is, and Akash is also a very lightweight protocol, so it doesn't do verification, doesn't do a lot of things by design, right? Because we believe protocols should be built upon each other. Like that's how internet works. That's how open source works, right? Like I build software used by Nvidia builds software used by us, right? So that's how we grow as a society. And I think like Akash is a foundational layer, base layer, and it is going to remain simple. It has to remain simple. Bitcoin is simple, right? Bitcoin should not be, I think, the functionality should be very, very, very focused on what the Bitcoin does. And similarly, Akash has to be very simple, so you can layer other protocols, right? So on top of Akash, and that's really how we see. Now, will Akash be the most value capture? Probably not, because it's usually higher level functions that capture more value than the protocol itself. Like, is Google web browser more valuable than Facebook? Probably not. Right? So that's how it becomes, right? Facebook is definitely a lot more valuable. Way more value capture. It's usually the higher order functions, higher order abstractions capture more value. But will it be most widely spread? Probably, yeah.
What? I got a couple more questions. What do you? Any other DePIN projects you're excited about that you think people should be aware of and follow?
Well, you guys are doing a great job, Fluence, right? I think I want to.
Right, Hans. Thank you.
Broadly speaking, I think interesting. So, I mean, they're obvious, contenders. I mean, Masari's DePIN network report is great, but upcoming DePIN networks that are not being talked about quite a lot is Althea. I think they're pre-launch. They are generating very impressive amounts of revenue, but they are decentralizing wireless, and they've been at it for a very, very long time. Highly recommend folks check it out. Let's see other DePIN networks I'm really excited about. I don't know. It's hard for me to get really excited about things.
Fair enough.
Older
fair
networks,
enough.
right? The older networks, I think, are doing something interesting. Like Filecoin's doing interesting stuff. I think Filecoin has like 2% of global storage now, which is crazy.
It's crazy. I didn't realize that.
There are. I'm interested. In fact, what I like to see, that are not there yet, is decentralized power. Like, power is such an important aspect. Without power, there's nothing, right? I want to see jurisdictions that are friendlier to innovation. Oh, I actually got to jump to another call. Sorry.
Okay, all good. Bitcoin prediction, and then how do we follow you?
Bitcoin prediction.
Bitcoin prediction for the end of this year. End of the year.
Yeah, God. I think I hate doing this, but end of the year, I think it'll be 100K.
Okay, fine, easy. Agree with you. Hard to agree. And then how do people follow you? How do people follow Akash?
Follow me, Greg Osuri, on Twitter. AkashNet _ on Twitter is the best way to follow me. Follow us.
Fantastic. Well, listen, thanks for joining. Really appreciate it. Super fascinating conversation. Thank you, Greg.
Thank you so much, Tom. Later.